Hello and welcome to our STEAM project number 9, based on the Raspberry Pi Pico and MicroPython. These lessons are designed for the somewhat experienced STEAM teacher. We call this intermediate level the Sherpa level. In this lesson, we are going to capture and interpret the signals from an infrared remote control to make LEDs go on and off. We are also going to work with the hexadecimal system and learn about the importance of this system in programming. My name is Peter. I am the founder of Educomondo and a certified STEM instructor and course developer. The goal of today is to switch LEDs on and off by means of an infrared control unit. We will learn how to integrate the infrared receiver and transmitter. We will learn how infrared signals work. We will work with hexadecimal numbers. And, most importantly, make sure your class works as a team to find solutions, help each other, and present their project in a clear and concise way. In our previous Arduino lessons, we already explained infrared light and its relation to heat. You can ask your class if they still remember what is the frequency of infrared light. Take a look at this spectrum chart for the answer. If they still remember, you can swiftly move to the setup of this lesson. If not, explain again or refer them to the lesson on the passive infrared sensor. That was lesson number 12, the guard dog. Let's take a look at what we need for this project. The first device that we need is an infrared transmitter. We all use these each day to switch on and control electronic equipment such as televisions, air conditioners, heaters, lights, or to open gates. Did you know that each time you press a button on a remote control, that the infrared diode switches on and off 38,000 times per second, or 38 kilohertz. The next component is the infrared receiver. In the Key Studio Starter Kit, this is nicely integrated on a circuit board, including a small control LED. There is infrared all around us, so how does the receiver know which is the correct signal against all of that infrared noise of the sun and other heat radiation? Well, first of all, that's where the 38 kilohertz comes in, because that is rare in nature and thus can be distinguished from ambient noise. Secondly, a signal modulation technique is used. In infrared signal modulation, an encoder on the infrared remote converts a binary signal into a modulated electrical signal. This electrical signal is sent to the transmitting LED. The transmitting LED converts the modulated electrical signal into a modulated infrared light signal. And the infrared receiver then demodulates the infrared light signal and converts it back to binary before passing it to the in microcontroller. So what else do we need? We need our large breadboard with the Pico installed and the pinout reference card. We take 3 red LEDs, 3 resistors of around 150 ohm, 220 ohm will also be fine, but the brightness will be a little bit less. We will also need a bunch of short and long preformed wires in different colors, and of course, the most important, the cardboard house. That's it for the hardware. And this is how the completed project looks like. As you can see, it is not that difficult, and your class should be able to do this as a teamwork. You can print the Fritzing drawing and hand it out to them, or you can keep it projected on the wall or whiteboard, whatever is available in your classroom. Give your students 10 or 15 minutes to build the project on the breadboard. Before we get into the programming, we will first explain the hexadecimal system. You all know about the decimal system, and we have seen the binary system, but did you know that there is also something like a hexadecimal system that is based on 16 digits, because hexa actually means 16. So let us give it a try to count to 16 or 15 in the hexadecimal system. So we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we end at 10 in the decimal system. We would actually go to the next position. But with the hexadecimal system, we can continue. And we continue with a letter. We gave A, which is then 10. B is 11, C is 12, D is 13, E is 14, and F is 15. So if you want to go to 16, we have to go to the next position. In other words, 16 will be 1, 0, 17 will be 1, 1, 18 will be 1, 2, and all the way down to the IF. Now, let us give it a try to calculate something. For instance, what would 3D mean in or be in the decimal system? Well, 3D means that you have 3 times 16 plus, and what was D again? This is 10, 11, 12, 13 plus 13. So 3 times 16 is 48 plus 13 is 61. Now, if we would go all the way down here and have FF, what would that be? So FF would be 15 times, because we know that F is 15, 15 times 16 plus 15. And guess what? That is 255. That would also mean that if we go to the next position, because we want to have 256 for instance, that you would be looking at 100 as 256 in a hexadecimal system. Now, why is this important? Well, the hexadecimal system is often used in computer programs to make numbers as simple and easy and short as possible. FF is a lot easier to write than 255, let alone a long string of binary numbers. And for our infrared project, this is important because infrared signals are often written as hexadecimal numbers. So when creating a dictionary to translate these signals into something meaningful to happen, for instance displaying the number that you have pressed on the remote control, it is a lot easier to do this with hexadecimal numbers than with long strings of binary numbers. But how do we get these hexadecimal numbers in the first place? Well, this is where we need to connect to Pico and do some live programming in Thonny. To make our project work, we need to complete 3 steps. First, we need a program that allows the Pico to capture the signals of the infrared sensor. Next, we need a program to display the hexadecimal code that is triggered by the different buttons on the infrared remote. And then we need a program to interpret or translate the hexadecimal code into the value of the buttons on the remote control. In other words, when pushing the button with number 1, the RPI will display the number 1 and not the hexadecimal number. In addition, we want LED number 1 switching on when pushing button 1, and the same for button 2 and 3, switching on LED 2 and LED 3. And when pushing 0, this will switch off all of the LEDs. To receive the signals from the remote control correctly, the best way is to look for a library or a piece of code that already exists. From the KeyStudio website, and you can see the URL on screen, download the Python programs called infraredReceiveData.py and project_31.1 decoded infrared signal.py. Because the latter refers to a project in the MicroPython project kit of KeyStudio, you can, without any trouble, rename it to, for instance, infrared_remote.py. It's important to save these 2 files in the same directory, either on your computer or on the Pico. In our case, I have saved it on the Pico itself. Run the program infrared_remote.py and one by one push the buttons on the remote. You will see that each button generates a unique hexadecimal code. Take note of these codes and the corresponding value, as we will need these to build a library for our next program. You can name the star symbol, for instance, star, and the up arrow up, and so on. It's not a bad idea to push the same button a couple of times and see whether the same hexadecimal code is generated, because sometimes it might generate some gibberish and you will be capturing a wrong number. So do it a couple of times. Just for fun, I have taken another remote with colored buttons. You never know that we will use these in a future project with colored LEDs or an RGB LED. As you can see, the same applies, and my button red triggers the hexadecimal number OX807FF00F. And you may notice that this hexagonal number has a different structure and consists of 10 digits, while the other remote sent out 9 digits. Note that this will not work for all infrared remotes because different remotes use different protocols. Okay, here we are in our Thonny environment, and the first thing that I want to do is to add a couple of comments. For instance, type here that this is lesson number 9 and it's called the Smart House. It's always a good practice to recognize the original authors of the code. So in this case, we can type something like based on code by Key Studio, because that's what we have been using in the different phases of this project. Now it's time to import a number of classes and modules. So from infrared receive data, import get command. And as you can see, you have to be very careful about the way these are spelled, because otherwise you will end up in trouble. From machine, we will import pin, and from time, we will import sleep. Okay, in the next phase, we are going to create a number of objects, and first we need a pin to which we are going to receive the infrared signal. So receiver pin, let's call it, and the receiver pin is infrared get command, and in between brackets we type 16 because that's the pin, the GPIO number that we have used. In the next step, we are going to create our LED object. So let's call it LED number 1. And LED number 1 is pin, and as you remember, we've put it on pin number 18, and it is a pin dot out. And the same for LED 2, 3. So I'm just going to copy paste. So LED 2 will be pin 19, and LED number 3 is going to be pin 20, and LED 3. Okay. So that's the first thing that we need to do. The next big step that we have to do is we have to create a dictionary, and a dictionary is a grouping of keys and corresponding values. And in Python, MicroPython, it is created by putting these couples, these keys and values together in between curly brackets. Now, what do we want to put there? First of all, we give it a name. So hex, let's call it the dictionary hex, equals, and then a curly bracket to open it up. And the next step is that we are going to use one of the hexadecimal numbers that we have noted down so nicely. And so for instance, the first one is 0xFF6897, and then colon, and this is number 1. And a comma. The next one is going to be 0xFF9867, in between or hyphenated, and this is our number 2, or our button number 2. So make sure that you're not making any mistakes. And just to speed up this session, I've already prepared all of them here, including the ones from our colored, okay, we are our colored remote control. And I'm going to put it here. That should be okay. Let me double check. Okay. Not sure whether it will have an impact, but let's just, because then it will look very nice. Okay. Okay, that wasn't that bad. It's a bit of yeah, a tedious little job, but once this is defined, once you have created it, it will make life a lot easier, and you can reuse it in any other program that that you might be using. In a later session, we will even teach you how to define this as a routine, so that you will be able to actually copy it very easily into other pieces of code. Okay, the next step is our while true loop. So while true. And here we say, or we look for an infrared key. So we create a variable infrared key. And the infrared key is actually just the value that is being received on the receiver pin underscore read, and so closing the brackets. So that's the code that we need to add. I'm just looking at all of the correct spelling. Now, what is the if statement? So if there is a value, if the receiver pin recognizes something, so if there is an infrared key, what do we want to do? Well, we are going to print the dictionary value, and this is a little bit playing with rounded and squared and other accolades in key. Okay, so that's the way to do it. And in this case, we are also going to, so not only to print it, but we are also going to go into another one. So if this is just to print it, if you also want to show the LEDs, if you also want the LEDs to go on and off, then we have to add some if statements. So if the infrared key value is equal to, so double equal sign, and then we have to use again the hexadecimal number, so OXFF6897. What do we have to do? Well, the LED 1 has to be put on, but we also have to make sure that LED 2 is off, and idem for LED 3 off. Okay, so that's the first one. If our infrared key double equal sign equals its OXFF9867, what do we want to do? Well, it's going to be the second LED that needs to be on. So I'm just going to copy and paste this so that this one will be off and the second one will be on. All the rest will be off. And then let's do it for the third one. So again, copy paste. Be careful with the indents. So if it's going to be 3, so that's OXFFB B04F, then we want the third one to be on. Good, and we also said that if it's going to be 0, then all of the LEDs will be off. So I'm going to do it here. If the infrared key variable is the hexadecimal number for 0 was 0xff for a B5. Don't forget the colon, then LED 1 will be off LED 2 will be off and LED 3 will be off. Okay, that should be enough for the programming. So let us give it a try and see if it works. No error messages. So I'm going to take the infrared control and push it on 1. Yes. Put it on 2. Yes. 3. Oops, an error message. Sometimes it happens that, as you can see, it is in one of the files that we have downloaded. So the only thing you can do is actually rerun the program and see if 3 is now working. Yes, and that's working. And if I do 0, then all of them will be off. So let's take also a look at how it transfers, or how this translates into the different LEDs. So if I do 1 again, you can see that LED 1 is going on. 2, 1 goes off and 2 goes on. 3, everything goes on. So looks like everything is working. I hope that it works the same for you. If it doesn't work for some team in your class, do not panic. Ask them to do some logical fault finding. Were there any error messages in the RPI of Thonny? Did you select the right Pico? Did you connect the components to the right GPIOs? Are there any loose wires or legs? Does your infrared remote support the correct protocol? Or maybe you're just unlucky and you picked a broken infrared sensor or LED. That's it for lesson number 9. I hope you and your class enjoyed it. For now, we are leaving the world of sensors and actuators to set our first steps in game development. In lesson 10, we will write our first game, guessing a secret number. Looking forward to welcoming you again, and bye-bye for now.